Well, hi there. Thanks so much for showing up for your learning. It's Mr. Jennings, and I'm at home in my lovely office. And you might be wondering what this chair's for. Well, I'm just gonna have this stuffy keep me company while I do some math. All right, so that way you know that I'm not doing this alone, and we're all in this together. Okay, there. All right, so let's get started, everyone. We're going to just do some delta math. I'm going to share some tips and tricks for all of these topics, and we're going to get them going good. All right, so let's go determine intercept from factored form. Here we go. All right, so we've been asked for the intercepts. Over here, we're going to make me smaller so that it's better. And then with these ones, I know that like they're sign flippers, right? So if I have x plus 1 multiplied by x plus 2 equals y, but I want to know where this thing crosses the x-axis. That's the x-axis. Well, the value of y is 0 along here, so I just set this equal to 0. And so I have x plus 2 equals 0, or in other words, x equals minus 2, right? 2 minus 2 is 0. Or x plus 1 could have been the one that was 0. Let's write that another way. Just kind of wish that these were written the other way. 1 plus x equals 0. So 1 minus 1 equals 0. X is minus 1. All right, so those are the two answers. And answers. All right, and so those happen at minus 1, 0 and minus 2, 0. Okay, that's how you do them. So there it is. Okay, again, next problem. All right, so these ones, minus x minus 4. Isn't that the ugliest thing? It's just so ugly. I never show you stuff like that, right? It's because I value your, I don't know, time, your eyes, just expose you to such ugly things. If you have negative x minus 4 equaling 0 in some way, well, that would be the same thing as, like, let's add 4 to both sides. Okay, so then we will have minus x equals 4, and then let's multiply both sides by negative 1, x equals minus 4. Yuck! So x equals minus 4 and x equals minus 5 are correct. There it is. And don't get fooled by that one, because those list those as y values, not as x values. It's alphabetical, everyone. The x is first, and the y is second. So don't be fooled. What? What? Did I click the wrong one? It asks for the y-intercept. Frick. Read the question, Mr. Jennings. Read it. Read the question. Okay, determine the x-intercepts. Okay, I got you here, fam. I got you, fam. It's that one, right? They're sign flippers. All right. Next problem. Determine the y-intercept. Okay. Dude should try his own homework assignment. What do you say? Okay, so let's see. Okay, so I want to know where this crosses the y-axis. Okay, in this case, we're just interested in this point here, because we want the y-intercept. So we set x equal to 0 because when x is 0, you're on the y-axis. So we from here have minus 0 minus 5 times minus 0 minus 3 equals y. Okay, minus 0 minus 5 is the dumbest thing I've written today by a long shot. But this would simplify down to minus 3 times minus 5 is y, and that's positive 15. So 0, 15 is correct. You just set x to 0 and evaluate what y is. That's how you find a y-intercept. I was like, I don't know, I probably told you that in the first week together, and you've forgotten. But if you think about what a graph looks like, not only will you understand, but you'll remember for next time. And if you forgot this time that that's how you do it, oh, but I told you before, says the math teacher. Well, the thing is, I told you, maybe you did it, but you didn't understand it. perhaps because you didn't try to understand it. Okay, we've been asked for the y-intercept here, so I make the x is 0. So that basically means it's like 3 times minus 2. So that's a minus 6. It's that one. Submit the answer. Yay! Next problem. Okay, we got x plus 5 times x plus 1 is y. The y-intercept is going to be at 5 because I set the x's to 0. So it's this one. Yeah. Next section. I didn't get that perfect. Oh dear. Okay. Lydia is throwing balls up in the air. The graph below shows the height of the ball, h in meters after t seconds. She actually whips it pretty high in the air, and it rises 4.9 meters in 1 second. The coordinate, the x-coordinate or t-coordinate, right, because that's time in t seconds, is 1. And it represents, let's see what our options are. Come on, options. How long the ball has been in the air? Yeah. The ball's height? No. How long the ball has been in the air? At its peak. I agree. Yeah. So that's the coordinates of the vertex, right? This vertex here, 4.9, corresponds to wee. It goes up and it's there. Okay. The y-coordinate is 4.9, and it represents the ball's height at its peak. Ooh, yeah, I got it. So we're interpreting. Ariana throws a ball up in the air. It shows the height, h in meters after t seconds. Okay. What is the ball's greatest height? 4.9 meters. Wow, same graph. Basically, not the same question. But, oh my god. They're on the same graph. Dude, just try some homework assignment, am I right? I'm like, oh great, I want my students interpreting the same quadratic over and over again in context. Okay, kicks a football. H meters after t seconds. After how many seconds does football hit the ground? Well, it's at 0, meaning it's on the ground, after 2 seconds. Okay, just... very different quadratic. A rocket, all right, is launched into the air. Shows the height. How many seconds have gone by when the rocket is at its highest point? 19.5 seconds. I just look at the t or the x bit there, right? 19.5 seconds. And how high is it? Oh, 6,000 feet. I was going to say 6 kilometers. It's like, wow, I went fast. But no, didn't go 6 kilometers in the air. It went 6,000 feet, which is still pretty darn high. It's like nearly 2 kilometers. Okay, all right. This is a really fast rocket. 19.5 is the answer. Yes, you need to take a deep breath to do delta math. I'd recommend 1 breath per question. The rocket is launched in the air. Great. My favorite type of question. After T set, find the interval for which the rocket's height is increasing. I love this question. When is the rocket rising? All right, it's rising for some amount of time. There's a time where it stops rising and it starts coming down again. Okay, we just want this time. Okay, this time. All right, so let's do it. So it's from 0 is less than or equal to 20 seconds. But is t? What? Sorry, that was me realizing out loud how they wanted the answer. Okay, we want to be able to give an interval for time. Okay? I promise this will make more sense. Okay, we want an interval for time that describes 0 seconds all the way to 20 seconds. Okay, that's the time when it's increasing, just up to 20 seconds. I wonder if they might prefer that, where it's really at 20 seconds, it's no longer increasing. It's like, it's not increasing, nor is it decreasing. It's just like, that's its motionless instant, and then it comes down again. Okay? So t is all the values that are greater than or equal to 0 or less than 20. If it tells me I'm wrong, I'm actually right. But I'm being too specific. Oh, there we go. Yeah, it loved it. Alternative notation. Okay, so it would have taken it with inclusive or with not inclusive. That's interesting. I've not really seen that. That's cool. Okay, so there you go. And look, it visually shows you the interval where it's increasing. That's cool. Yeah, and this is more of a topic for us this coming week. We're going to do stuff on these types of things. Okay, let's go. Standard to vertex form. We want to write this in vertex form. So we're going to CTS. We're going to complete the square, or we're going to find the vertex and just get her done. Okay, so I want to put that up high. I want to get more space for my scratchy pad. So bring my scratchy pad up here. All right, we're going to complete the square. This is method number 1. Complete the square looks like this. Copy it out on your blank paper or your infinite electronic paper, whatever you use. Leave a bit of space, plus 36. Okay? And then because a equals 1, we don't need to do step 1 of factoring a out. Yay! So we just take half of that number, minus 20 on 2, okay? And we square it, and we get 100. Oh my, he does all that mental math in his head. It's not hard, folks. It's minus 10 is minus 20 divided by 2. And then I square that. It's 10 times 10, but positive, is 100. So I add 100 and subtract 100 in the same place. And then I recognize that this is a perfect square trinomial. So that is y is equal to x minus 10 squared minus 64. That is the complete the square vertex form. So I type this in. It's already got y equals for me. Isn't that just so convenient? What am I typing? I pushed shift in the wrong time. X minus 10 end the bracket, square the bracket, get back down on the line u, minus 64. And it wants me to tell it the vertex as though it doesn't know. It knows, but it's like playing coy, pretending it doesn't know. Okay, so wait, I see minus 10 there, Mr. Jennings. Why did that become positive 10? Did you just make an error? No, that one is a sign flipper. Well, why didn't you flip? Okay, this is my student voice. I should have a little hat. I could puppeteer. Okay, it goes like this. Hey, Mr. Jennings, why did you flip the sign on the 10? Is that an error? No, it's not an error. That one's a sign flipper. Then why didn't you flip the sign on the 64? Hey, that one isn't a sign flipper. That one tells the truth, according to some math teachers. Numbers are always telling the truth. That's why I put that in quotes, because I think that's rather quaint. Okay. Yay! Let's go. Next problem. Okay. But, Mr. Jennings, didn't you say there's alternatives to complete... Aren't there alternatives to completing the square, Mr. Jennings? Yes, there are. There are. Let me show you. Let me show you some ways. We just find the axis of symmetry. Okay, so we know that if we had like x equals negative b plus or minus the square root of some stuff in there over 2a. Okay, all that is the plus or minus. Okay, this is a quadratic formula, but this here gives us the axis of symmetry. It's like the part of the guts of the quadratic formula. So let's do that. Here our a is equal to 1, x squared, just 1x squared, and our b is equal to 14. So we do negative 14 over 2 times 1, which is equal to negative 7. Okay, that is the value of the axis of symmetry. This quadratic looks like this, folks. Crosses way up there at 40. Okay, comes down, comes up again like that. No, it doesn't. I don't think it crosses the x-axis. I don't even want to figure it out. It doesn't. No, wait, no. It does. Anyhow, yeah, it does cross. But yeah, it goes like that. And this here is at 7. I think we're going to find that it's negative. Yes, it's negative. It's negative 9. So anyway, so my sketch isn't that great. But we found that this is x equals 9 is the equation of the axis of symmetry using our little negative b over 2a formula. Oh my gosh, I'm just looking at my notes and they're just so gnarly. I'm going to, please let me start again. Okay, if you've been with me this long, you're going to like this. Okay, there it is. It comes down here, goes down to -9 and goes back up. So that's the vertex. This is so bad. Okay, we can use, okay students, tune in now. We can use this special formula, negative b over 2a, okay, to find the equation of the axis of symmetry. This line, whereon lies the vertex. The vertex is always on this line. Negative b over 2a. In this case, b is 14. A is 1 in this quadratic above, as you can well tell. So when I process that, I get negative 14 on 2 times 1 equaling x. Well, that would be negative 7 equals x. So this here, friends, this is the point 0, 40. Okay, that's the y-intercept. We can see that from the c value. And then we know here, this is the point negative 7 something. Okay, we need to calculate that something, and we would do it this way. F of x is equal to x squared plus 14x plus 40. Go ahead and put f at 7, negative 7 in there. When you do it like this to be just oh so ever clear. Everclear, that's a band I haven't heard in a long time. Okay, so we're just going to substitute -7, which we know to be the value of x at the vertex. All right, so once we do that, we just process it, okay? So f at -7 is going to be equal to 49 is 7 squared, minus 98 is 14 times -7, plus 40. When we do all this, we get -9. Like I told you, what was it, 5 minutes ago? And I do apologize for the... I blame you. What? It's not my fault that you're not organized. He even called me disorganized. That's unkind. It's unkind because it's true. Okay, so here. So what do we do? Okay, we now know the vertex, right? We know the vertex is -7, -9. So we need to write it in vertex form, okay? -7, -9. So that would look like this. Y equals, or f of x equals, x plus 7, because that one's a sign flipper, squared -9. That's the vertex form of this quadratic. And the a value equals 1, because the a value never changes when you change the quadratics to different forms. Doesn't change. So we write that in there. X plus 7 squared -9. The vertex is at -7, -9. Submit the answer. Let's do one more. This time I'm just going to do it, okay? I'm just going to do it. So that's 10. Y equals x plus 10 all squared plus 120. The vertex is at -10 and 120. Oh, what did I do? Of course, it's at -80. Jeez, I should visualize these things. I was really just trying to really go fast and impress you, but I impress no one with my incorrect maths. Okay, good. All done. That section. Oh, next, standard vertex form, where a is not 1. Okay, yeah, okay, cool. All right, so these ones we have to do the way I taught you. The way I taught you works for the other ones, as you've seen, when you don't make a silly error. Yeah, you impress no one. It's just twisting the knife. Okay, so here we're going to now have to do step 1, which is factor out a from the first two terms. Okay, so we're going to have y is equal to, I'm just going to copy it, 2x squared plus 12x minus 24. First step is to go y is equal to minus 2 multiplied by x squared minus 6x, leave lots of space, minus 24. Okay, we have to leave lots of space because that's where we're going to be adding and subtracting the magic number. And positive 12 divided by negative 2 is negative 6. Your calculator tells you if you're confused. So now we prepare our magic number. Our magic number is minus 6 divided by 2 squared, which is the same thing as saying minus 3 but in brackets squared, which is the same thing as saying 9. So we add 9 and subtract 9. Then we recognize that that, friends, is x minus 3 all squared. Okay, we've created a perfect square trinomial by doing that. So we have y is equal to minus 2, x minus 3 squared. This minus 9 would love to get out of the brackets, but when it does, don't forget to multiply it by that minus 2, so it becomes plus 18, and then we still have this minus 24. Okay, when this one escapes, it has to be multiplied by that. Don't forget, it's still inside those brackets. Team. Okay, so now we just finish by saying y is equal to minus 2, x minus 3 squared minus 6. That's minus 6. So that's a lot of minuses. Y is equal to minus 2 bracket x minus 3 and the bracket, square the bracket, minus 6. Let's do the next one. Okay. Let me showboat. I'll do this one in my head. Y is equal to 9. That's going to factor out. This is going to be x plus 5 all squared. And then we have to add. We've got to subtract 25. Plus 4. I can do these in my head, you know. All right. Let's do one more. Oh, right. But isn't there a different way to do this, Mr. Jennings? Don't you want to show us a different way besides just like doing it in your head? Actually, when I did that in my head, I did complete the square. In my head, I didn't do it this way. And this way I find easier. So that wasn't some weird flex. I guess it was. I'm so sorry. Okay, so we're going to do it this way. We're going to say y is equal to minus 4x squared plus 32x minus 66. We remember that the axis of symmetry is at negative b over 2a, which in this case, b is 32, so that's minus 32 over 2 times minus 4. Okay, so this is equal to minus 32 over minus 8. In other words, 4. Okay, so the x value of the vertex is at 4. So now I'm just going to call this f of x for now. And actually, I just want to find f at 4. So permit me my pretty little substitutions here. So I got minus 4 multiplied by something squared plus 32 multiplied by something minus 66. I'm going to put in my pretty substitutions there. We're going to have 4, 4, calculate. Okay, so we calculate this. So f at 4, meaning the value of the function when evaluated at the vertex, is going to be, this is 4 squares, is minus 64 plus 128 minus 66. That, in other words, is 64 minus 66. That's minus 2. Okay, so what do we do with this information? Well, this information is critical. This is telling us that the vertex is at 4 minus 2, okay, which is what we wanted to know. And if I write this out in vertex form, then that would be y is equal to, the a value doesn't change. I just take that number, port it over. X minus 4, because this one's a sign flipper, squared minus 2, okay? Y is equal to minus 4 bracket x minus 4 and the bracket, square the bracket, minus 2. I think I wrote that down right. Yes, I did. Submit. There. That's how that way do. Okay, and I find that way is just like better for my money. Like I would rather do that than complete the square. Use the quadratic formula to solve. Okay, sure, fine. What? I am not free plan. I am paid plan. You get out of here, mister. I'm gonna go just sign in a second. I can't sign in while I'm making a video, so anyway, I'm just gonna show you how to do these. Okay, so this one here, we're going to use the I'm gonna go really fast. All right, so we're gonna use the quadratic formula to solve. First thing that we're gonna do, 13t squared minus 8t plus 1 equals minus 3t squared. We need this set to 0. So then we get 16t squared minus 8t plus 1 equals 0. Okay, so then we create our little sheet. A equals 16, B equals minus 8, and C equals 1. And then we sing the song. T equals, I thought it was X equals. Well, here we've got T, so whatever. T equals negative B plus or minus the square root of B squared minus 4AC over 2A. And then we sub in, negative b is positive 8. Yes, sometimes I do that. Okay, I could do negative 8, and that'd be the same. Plus or minus the square root of negative 8 in the brackets squared minus 4 times 16 times 1. All of them in brackets divided by 2 times 16 equals... Oh, it says express your answer in simplest form. I can't ask you these questions. I'm going to change this one. This one's not even going to be on there. This is going to be 8 plus or minus the square root of 64 minus 4 times 16 is 64. Okay, all over 32. All right. Well, that is to say 8 plus or minus 0, because the square root of 0 is 0. Okay. Don't make me write square root 0 and then tell you that it's 0. Over 32, well, that is to say that's 8 over 32, which is 1 over 4. Okay, yeah, these are rational. So these are, yeah. So t is equal to 1 over 4. Yay, so that's how you do those. They'll all be rational. You never need to do funny stuff. If you have decimal answers, okay, to the nearest 10th. All right, let's do it. Okay, so if I want to solve that to the nearest 10th, then I'm going to do this. Let's change colors. I like working in orange. This is like my new favorite color to work in. Okay, so we got 3x squared minus 14x minus 13 equals 2x squared. Well, that's nice. So we subtract 2x squared from both sides to set this equal to 0. We get x squared minus 14x minus 13 equals 0. Now we're ready to go. A equals 1, B equals minus 14, C equals minus 13, and then we plug it into x equals negative b plus or minus the square root of b squared minus 4ac over 2a. What is my hand doing? So weird. Okay, then we plug in x equals negative 14 plus or minus the square root of 14 squared, in other words, negative 14 squared, which is the same thing, minus 4 times 1 times minus 13, all over 2 times 1. Okay, so then what's next? Then we got x equals 14 plus or minus the square root of 196 plus, because it's minus times minus, plus 52 is 4 times 13. Learn your times tables, people. Times tables haven't changed since you were in the years that they taught them to you. So maybe learn them. Okay, x equals 14 plus or minus the square root of 248 over 2. The square root of 248 has got to be pretty big. It's got to be a little less than 16, a little more than 15. So let's just evaluate. Okay, so at this point we evaluate on calculator. right? I don't know what I was doing there. Oh, right, teaching math. Okay, so then we're going to do 248, but take the square root, and that's what I said it would be. And then we're going to add that to 14. That's the numerator in the positive case. Divide it by 2 is equal to this. Okay, so now that's one of the positive ones. Okay, and then notice we have to have multiple solutions here. So I'm going to say to the nearest tenth, that's 14.9, because the 7 make 8 round up, okay? And then I say additional solution, and then I'm going to go in here, and I'm going to say, just get my calculations back. Gosh, there. So I have 14 minus 248, but I take its square root, equals some little negative number, divide it by 2, equals negative 0.9, because the 7 make the 8 round up. Okay, so it's the wrong place. Here. So negative 0.9. Submit. Good. 5 of those is a little much. I'm going to lower the number of those that you have to do to 3. Yeah, and then that will be good practice. Okay, let's go back. I wonder if I can do the last question type. Finding the discriminant. Finding the nature of the roots given discriminant. We're going to do this in some time practice. Okay, start. If the discriminant is 0, they are real, rational, equal roots. If the discriminant is minus 31, they are imaginary. If the discriminant is 32, they are real, irrational, unequal roots, because 32 is not a perfect square. 0, when the discriminant is 0, they are real and equal. There's one root. It's the vertex. Okay, if it's 0, it's real, rational, equal. Okay, discriminant 94, that's not a perfect square. That's real, rational, real, irrational, unequal. That's imaginary. That's real, rational, equal. Imaginary, real, rational, unequal. Okay, there. So that's what that skill looks like. Try that one. This one, finding the discriminant. Okay, so finding the discriminant, we want to be able to do, to be able to calculate the discriminant, which is to say, we have this little thing, b squared minus 4ac, can tell us a lot about the nature of the roots of the quadratic. That's the thing that builds this part of the quadratic formula. If it's negative, the roots are imaginary. They do not exist in the real numbers. If that's a perfect square, they're rational and they're separated in some amount. If that's not a perfect square, they're irrational and separated. And if it's a 0, then the vertex is the one and only root. So here we want to do like our a is minus 5, our b is 2. This is all from the example up there. And our c is 43. And we're just going to calculate the discriminant. So it's going to be 2 squared minus 4 times minus 5 times 43. Now look for easy ways to do this multiplication. Don't multiply 5 times 43. Do minus 4 times minus 5 first. This is 4 plus 20 times 43. Isn't it easier to multiply 43 by 20 than by 5? I think so. It's 860. So this is 4 plus 860 is equal to 864. Let's go, next problem. Do these in your head for fun. Okay, so it's 400 plus 400 plus 400 is 796. Ask me how I learned to do that. I learned to do that by practicing. Okay, yeah, I'm glad. Wait, how did you learn to do that? I learned by practicing. Okay, so let's do some more practice. Ooh, I have to move that over by adding 3 to both sides. So my C value is 47. Let's see if I can do this. 36 plus 956. Scandalous. Okay, 36 is definitely that. 47, not 46. 47, not 46 when I moved the 3 over. I even said so and then did it wrong. Okay, so 47 is 20, 940, 976. Yay. Hooray. Oh, okay. Now you're talking. Minus 5. 81. Oh, this one is gnarly. Let's see if I can do this one in my head before the time runs out on this video. I doubt it. Okay, 5. 18 squared. 324 or something like that. What is it? D324. Okay, that's why I got 324. Plus 5. It's always 20 times. That's hilarious. 20 times 81. 1620. 16201944. That was hard. Okay, hard for me. Okay, maybe it's not hard for you, but it was hard for me, okay? And you got to celebrate your victories. Can't celebrate other people's victories. Well, you can. You should celebrate other people's victories. But you can't make any mistake about your victories. Even if they're smaller than other people's victories, they're still victories for you, and you should still celebrate them, okay? So I celebrated that one because that was hard for me, and I managed to get it right. And so I'm very pleased. And now I'm going to take a break. Okay, so I hope this is useful to you. And if you got stuck, that you get unstuck with this stuff, okay? You want to say bye? Don't forget to practice. I don't know what he's going to say. That's so... If they're already watching this video, they're definitely practicing, okay? Be proud of your practice. That's good. That's good. I like that method. You should be proud that you showed up for your math learning and that you're practicing. So the code word is ostrich margarita. And I will see you all later. Bye.